All right, let's talk about artificial intelligence. We're living in a world that's just swimming in data. It's a total flood. Every time you click something, buy something, or even just walk past a sensor, you're adding to this gigantic digital ocean. So the huge question is, how in the world do we learn from all of this when it's just too big to handle? Okay, let's dive right in.
You know, this quote from Peter Norvig at Google, it absolutely hits the nail on the head. Modern AI runs on data. It's the fuel. The more data you can feed it, the smarter your models can get. But, and this is a big but, having all that fuel is completely useless if your engine can't handle it. The massive amount of data we have now has become one of the biggest roadblocks in machine learning.
And when we say big, what are we really talking about? Well, we're generating quintillions of bytes of data every single day. Just think about it. Every smartwatch, every social media post, every single online order, it all adds up. We're way past megabytes and gigabytes now. We're living in the age of terabytes and petabytes. This is what we call big data.
So here's how we're going to tackle this. First, we'll look at the big data challenge itself. Then, we'll introduce the solution, a tool called Apache Spark. After that, we'll pull back the curtain on the magic of how Spark actually works. We'll also cover its key advantages, see it in action in the real world, and then wrap things up with the big picture.
Okay, first things first, let's really define the problem. Why is big data such a massive headache for the old ways of doing machine learning?
So think about how we used to do this. The old way was pretty straightforward, right? You had one big, powerful computer, and you just load up all your data into its memory to train your model. Simple. But what happens when your data set is bigger than that one computer can possibly hold? Well, that whole approach it completely falls apart. It's kind of like trying to bail out the entire ocean with just one bucket. It's just not going to happen.
And that's where our hero makes its grand entrance. When you have a problem of this size, you need a tool that was born for it. And that tool is Apache Spark.
So what exactly is Apache Spark? Well, the short version is that it's a framework designed for distributed computing. Instead of trying to force everything onto one machine, Spark smartly spreads the data and the work across a whole team of computers working together. And its real secret weapon, which we'll get into, is that it does all this work in memory, which makes it incredibly fast. Now, to really wrap your head around how Spark manages to do all of this so quickly and efficiently, I want you to picture something. Imagine a huge, bustling, state-of-the-art kitchen. This analogy right here is the key to understanding how it all works. So let's step inside this kitchen. How does Spark take a mountain of raw, messy data and turn it into a perfectly cooked 5-star insight?
It really breaks down into 4 key ideas. First, you distribute the data. So the head chef, that's Spark, divvies up all the ingredients to the different workstations. Second, you get parallel execution. This is huge. All the chefs start working on their part of the meal at the exact same time. Third, and this is the secret sauce, is the in-memory processing. Think of it like this. All the ingredients stay out on the counter where they're easy to grab. You're not running back to the fridge every 5 seconds. It's so much faster. And finally, there's fault tolerance. You know, what if one of the chefs has to leave? No problem. Another chef can just look at the recipe, pick up where the other left off, and the whole dinner service doesn't grind to a halt.
Okay, so we've seen the process, but what about the results? What makes this kitchen so much better than just having one person trying to do everything?
The first, and honestly the most jaw-dropping advantage, is raw speed. Because of that in-memory processing, keeping the ingredients on the counter, remember, Spark can chew through workloads up to 100 times faster than older systems like Hadoop MapReduce. We're not talking about a tiny little improvement here. This is a game-changing leap forward.
But it isn't just about speed. Spark is also incredibly scalable. You can just keep adding more chefs to your kitchen as your recipes get bigger. It's also a unified platform, meaning it can handle all sorts of data jobs in one place. Plus, it speaks multiple languages: Python, Scala, Java, R, so developers can use the tools they already love. And finally, it's just easier to work with. Its high-level APIs take a lot of the complexity out of building these massive applications.
So the theory sounds great, right? But where is this stuff actually making a difference? Let's look at some real-world examples that you probably use every single day without even realizing it. In the world of finance, every single millisecond is critical. So banks use Spark to sift through millions of transactions in real time. This lets them catch fraud almost the instant it happens, figure out credit risk across huge portfolios, and run the super-fast algorithmic trading that powers the markets. It's the engine that keeps our financial world moving safely and quickly.
You ever get that feeling that a shopping website is reading your mind? Well, you can thank Spark for that.
E-commerce giants are processing unbelievable amounts of data. Every click, every search, every purchase, to power those recommendation engines, understand how we shop, and even change prices on the fly.
And what about when you're just relaxing? You know those personalized feeds on Netflix or YouTube that always seem to know exactly what you want to watch next? That's all driven by scalable machine learning. Spark is in the background, analyzing what you've watched to predict what you'll enjoy next and keep you hooked.
And this is a big one. Spark is making a real, life-saving difference in healthcare. It can analyze massive collections of medical records and images to help predict disease outbreaks, help doctors spot issues in scans, and even identify which patients are at high risk and need attention now.
All right, let's step back for a moment and look at the whole landscape. What does a technology like Spark really mean for us and for the future? Here's the bottom line. Apache Spark has essentially given us the keys to the kingdom of big data. It lets us ask questions about datasets that were once just too big and unwieldy to even touch, and it gets us answers fast. That ability, right there, is what's revolutionizing entire industries and powering the next big wave of AI.
And that brings us to a really fascinating final thought. We've built this incredibly powerful kitchen, and we have an endless pantry of ingredients. So the question isn't can we cook anymore, it's what should we cook? Now that we have the power to analyze almost anything, what's the most important, most urgent problem we should point this amazing technology at next?